Today I'll be teaching the Nerlovian analysis, which is usually used in agriculture economics. The variables used in the analysis are production, lagged of production, minimum maximum temperature, irrigated area, area under production, and rainfall. All these are in log form. So next is to work on the equation. So my dependent variable here is production. With the help of control key, I'll be selecting the rest of the variables. Rest of the independent variables can be selected in any form, not necessarily it should be first and second. Only the dependent variable should be first, and then click open, and then later click equation, so you get the equation, but the lagged dependent variable is missing. So you have to type ln prod in brackets -1. You're closing the bracket, so the equation is in order, and click OK, and so you have got the answer for it. Now we'll explain the short run elasticity. For that I'll just click the word file over here. So you can see the lagged dependent variable, that is your production, where the coefficient is 0.57 and it is also significant. So what does that say? That is about 42.6% of the desired adjustment in production is achieved within 1 year. So while doing the Nerlovian analysis, one thing should be kept in mind, that is, if the lagged coefficient is negative or if it is not significant, then the partial adjustment mechanism does not hold. The next is how to explain the rest of the coefficient. See, in the case of minimum temperature, it is negative and it is not significant also, but it can be considered at 10% level significance. Next is your maximum temperature. It is the coefficient is positive as well as significant. So for that you have to write, it is indicating that higher maximum temperature within the observed range enhance production in the short run. Similarly, you have to write for the rest of the variables. This is for your short run elasticity. Now next, for your long run elasticity, for that you have to do a wall test. So for that, go to view. Before that, I will try to copy the equation over here, so it will be easy for me to explain to you all. So how did I get this C1? This is coefficient 1, this is coefficient 2, this is 3, this is 4, this is 5, this is 6. It will be in this order. So go to view, click coefficient diagnostics. From there move on to wall test or coefficient restriction, and I am just pasting the equation, and this I am just giving it, click OK, and later I am just going to the word file. See, for long run elasticity, your wall test should be significant. So it means what? It has an effect on agricultural production. All these equations has got an impact on the agricultural production. If the wall test is not significant, then what does it mean? It doesn't have a significant long run impact on production. So this is how you have to explain. But when you do these coefficients separately, sometime one of the variables might not be significant, but still you can go with this and you can continue with your results. Then later you have to check for serial correlation, heteroscedasticity and Ramsey. We'll do that also. Just go to view, go to residual diagnostics, where we'll go to serial correlation. Let the lag specification be default and click OK. So you can see it is p-value is greater than 0.05, so there's no autocorrelation. Then click stats over here, then getting back to view, getting back to residual diagnostics, then heteroscedasticity, then click OK. OK, fine. So you can see that Here also the p-value is greater than 0.05, so you don't have any issues of heteroscedasticity. And then again you're clicking stats. Just go to view, go to stability diagnostics, where you can come down to Ramsey reset test. Let the reset specification be as default. Click OK. Again, this also states that the equation is stable. This is how you have to explain your Nerlovian analysis. Hope you're clear with it.